Okay, good morning, everyone. I think it's about time to start. I will be recording this lecture next to so that you will get the recording so that you will see the steps when you are working with your project, like be a tutorial for how to use the software. But I also recorded another video on YouTube, which is very that's a video that also have the same steps that I will be showing today, but without conceptual explanation. So I'll record this so that you have both. So today, what we will be doing today is that everything we have learned this last 3 weeks, we will put them into an application. So let me just start here by just writing down what we have learned so far. And so that you will have the big picture of what we are doing. We have what we have learned so far is something that looks like this. X. Here is a K. DH, so dx plus y k dh over dy. Torture y, torture derivative. And that was equal to some storage term. Like delta. This is partial derivative. Partial, H partial. So I think this was one of the main things we've learned in the last 3 weeks or whatever. So we have this equation. It shows you how your hydraulic head or your head H change in space has H change in time. And we have seen that the hydraulic conductivity of your subsurface material, that is, if it's constant, that simple example where we assume this is constant, then you can get it out of these integrals. You can integrate this, do this integration for simple 1D case, not for a 2D case, for a simple 1D case, and you get a solution which you can use. But as you have seen, as we did last class, this hydraulic conductivity is not constant because when this is what we did last class. So this is what we did last class. So last class, what we did was something like this. This is our side. Okay. Our side looks something like this. Check. Have these notes with you. I give you some. Anyway, so I have it here with me. Okay, so we have from last class I gave you some pumping test data measuring hydraulic conductivity, electrical resistivity data, and from this you will be able to create a hydraulic conductivity field. So for example, you have something here, for example, K, you just assume K is equal to 8, for example, then you have something here, for example, and you assume K is equal to 1 150 or whatever this number is. Then you said, okay, we have like a parent river channel here that looks something like this, maybe. Okay. And we assume that K here is equal to, I don't know, like 300. And we said, like, okay, we have a high hydraulic conductivity zone here. And we say K here is equal to like 650, if I remember correct. And then we said, okay, we have like one zone, like from here to here, and K is equal to 20 or whatever this number is. And we said, like, we have K here, and that maybe 40 or whatever this number is. So here, I mean, this is how you conceptualize it, your site. This is just like an initial guess, as I told you last time, an initial conceptualization that we will keep improving as we calibrate this model. We'll talk about this later. So you see, like, your hydraulic conductivity. Like, if you see here in this equation, this is exactly what this equation presents. That your K value is changed with X, and your K value is a change with Y. Because like the hydraulic conductivity here is 8, for example, here it's like 20. Here is 8, here is like 20. So it's changing with Y and it's changing with X. Here K1, K2, all this like parameter K3, K4, K5, K6. So your hydraulic conductivity is not constant. So this means that like we cannot do this integration as we did before, and to solve this equation, we need to use a numerical method. To solve this equation, what we are solving for. So let me do one more simplification, like for our case studies that we would be doing. I'm telling you that H is not changing with time. Like H is constant. H is constant, like it's not, yeah, it's constant. This is the steady state, like your H is not changing with time. So this is like, if your H is not changing with time, then we can assume that this is like 0. Okay. So this term will be 0, and this will be like our governing equation for steady state condition for groundwater simulation. Like we are simulating groundwater in like steady state condition, where like the system reaches an equilibrium stage, so that H is no longer changing with time. So what we are solving for? Like look at this equation. What we are solving for? What we are solving for? The answer, what we are solving for? Like this equation. So we define the hydraulic conductivity, right? Yes. So what we are solving for? Like what do we want to solve for? So we define the hydraulic conductivity already, right? Yes. I mean, what is the unknown in this equation? So yeah, for H. Yeah, that's the only unknown in this equation, right? Because like in this equation, we define our hydraulic conductivity. This is like the hydraulic conductivities that we define, and that's how it's changing in X. Okay, and then we want to solve for H. So basically, I want to know what is like H, and like to do this numerically, we basically like to do this numerically. Like we're not gonna do it like analytically. We'll do it numerically. Like to do this numerically, we subdivide like our model space, into cells. So. Okay. And then we estimate like what is the H value here, for example. What's the H value here? What's the H value? So for each of these nodes, we can like estimate like the H value. Like we can estimate it either in the center of the cell or at the edge of the cell. You can estimate like your okay. At each node or at each edge. Okay. So basically that would be like a numerical solution. And to do this, we're gonna use a software or like code like it's called like MODFLOW. Okay. We're gonna use something called like MODFLOW. Okay. So MODFLOW if you gave MODFLOW like your basically, so you have like this equation. If you gave like your hydraulic, like this is your hydraulic conductivity in each of these zones, MODFLOW would solve this equation and tell you head here would be like this value, head here would be this value, head here would be this value, head here would be this value. So what MODFLOW will solve for, or what will be reduced, is like head value, the simulated head value. Is this clear or not? Everyone? Okay. But this equation is missing something. Like if you look at this equation, it is missing something. Basically, what this equation is missing is what is happening at like the boundary of my system, right? Because H will depend on what's happening at the boundary of my system. Like is water, for example, flowing out of here, or like coming from here. Because if I have water flowing out from here, water coming out of here, that will affect my H. Do I have like recharge that's happening on the top? That will affect my H, right? Like my head value, like if I have recharge, so this is like my aquifer, it looks like this. So here, this is like, let's say, this is like my aquifer, it looks something like this, okay? And then this is like the land surface is here, okay? And then I have like recharge here. This is like a recharge here. This is like my water table. So here like different H values. So if I have recharge, for example, H will go up, right? Yes or no? Yes. So this is like my water table. This is my water table. This is like my head value. So if I have like if water is replenishing these, what will happen to this water table? Will it go up or go down? Like I have recharge, like water is coming here. So this surface will go up or go down? Up, right? So if I have like recharge here, that will change my H, right? Yes. Now also let's say I have like a river here, okay? And like this river, for example, it is like feeding the groundwater, like it's a gaining stream or like a losing stream. That will also affect my H value, right? If I have like a pumping well, like let's say I put that's like W, that's like recharge here, that's like W. If I put like a pumping well here, and I start pumping like Q out, okay, like I start pumping, what will happen to my head here? Will it go up or down? So I have like pumping well, I put a pumping well and then I start pumping. This is my water table. What will happen to my water table? Like will it go down or go up? Yeah. Down, right? And do you know how the shape would look like? Cool. Yeah, you will get this cone of depression. So if I started pumping, then that thing will start to look something like this, right? You agree? So H, like this H, is also is subject to all these boundary conditions, right? So I have like different boundary conditions. Like, let me write that down. I have like recharge, for example. I have like a pumping. Well, I could have like a river. Right? Yes. So basically, so to make this equation complete, I will just like add like this W here, and that will include all like my boundary conditions, the boundaries that are acting with this system. Whether these boundary, so for example, like recharge, that's like will like be a source term because like I'm adding water to my system, right? While like pumping well, that would be what? Source or sink term? Source or sink? Like a pumping well, would that be a source or a sink term? Sink term, yes. Recharge, that's a source term because I'm adding water, like I'm adding like water Q to my system. Here I'm like, that's a sinker because I'm removing water from the, extracting water from the system. The river, is a river like a source or a sinker? Source. One is saying source and one is saying sink. It's both because it depends, like whether this is like a gaining stream or a losing stream. If the river is giving water to your aquifer, then it is like a source there. If like the water is losing, if your aquifer is losing water to the river, then it's a sink there. Okay, so it's both. Okay. So I could have like all these source and sink there. I also, like my system also has boundary. So like my system also has boundaries. So like for example, like in the problems that I gave you, I told you here, like this boundary here, this is like a no, this is a groundwater flow divide. Groundwater flow divide, this means that this is a no flow boundary, which means that like water, like if water, this like you can think of it like as a watershed, like water flow and then flow down. So any water that will flow on the top will just flow either in this direction or in this direction, but no Q here. So basically, if I told you that this is like no flow boundary, this means that like Q here is equal to 0 because there is no flow boundary here. So I have no flow is occurring here, and like also no flow is occurring at this boundary, and no flow is occurring at this boundary because this is the groundwater flow direction. So here I have like all these are like no flow boundaries. And here, like in my aquifer here, I have like a river here, and like that river again, that could be like a source or like a sink, depending on the head. Like so, if the head in the river is higher than the head in the aquifer, then it would be like water will flow from the river to the aquifer. If the head in the aquifer is higher than the river, then water will flow from your aquifer to your river. So these are like, and then I also have another boundary which is here. And this is again another no flow boundary. So this is like the bottom of my aquifer. I have a confining unit here. So again, this is also like a no flow boundary. So like Q here, like Q that goes down is like also equal to 0. So this is also again like another no flow boundary. Basically, that's all I'm doing. Okay, I have like this equation. In this equation, I define my hydraulic conductivity field. This is what I did here. Then I have to define like my boundary condition. So I have like a recharge, I have a pumping well, I have a river, and then I have all these no flow boundary. Mud flow, if you didn't define it, then that would consider it like a no flow boundary. So basically I have like to define like these boundary condition. So that's what I give to mud flow. I give to mud flow like this boundary condition. I give mud flow like these K values over there, and then mud flow will tell me the H at each cell or each node depending on what flow you're using. Okay. Now, this is what will mud flow tell me. Mud flow like will solve this and gave me like the H, the simulated head. Give me like the simulated head. How would I know that this simulated head that mud flow is giving me is like true or correct? How would I know that this value is like true value, like this simulated head? Yeah, the simulated value is true. How could you know this? So this is from my model, okay? Like my model mud flow is telling me the head here is this value, 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 and so on and so forth. How would I know that this is true? Exactly. You match it with the observed. So basically, so you go to the field, this is what I did, like what I showed you last time. So last time I told you we have like this different observation wells here, like we have like 12 of them. This is their coordinate, and this is the head measurement. And like we can use this head measurement, you can and like plot this head contour. Okay. So basically, this is what you observe it in the field. So this is like the head observation. So this you go to the field, you observe this value, your conceptualization or your understanding for the system, that's like your hydraulic conductivity field, your boundary condition, you put it in the model, and like you let MODFLOW simulate the head, and you compare it to what you observe in the field. If your model, like your definition for like these boundary conditions and for this hydraulic conductivity is wrong, you will never be able to simulate what you observe in the field. Is this clear? Is this clear for everyone? This is what I'm telling you now. This is the most basic concept that I want you to learn in this, like today and like the next 3 days. And this will be important for your project, like when you write your report. Okay? This is clear for everyone. Should I say it one more time? Like this table over there. The 4 of you, is it clear? Yeah. Clear for you? Clear? Clear? Can you explain it? Or is the class? Like explain how would we know, like for example, like that this model is like a good model or a bad model, and
yeah, you said it has to match your observation.
your observation in the field. Yes. So basically, like this, that's the most like basic concept. It's like I define like I have like an initial conceptualization of my model. Like here, I define my hydraulic conductivity field, I define my boundary condition, I run my model will simulate as a head. Then I will compare it to the heads that I'm observing in the field. If they match it, which will not happen, then you're done. But generally, when you do this, these two will not match because your conceptualization is not perfect. So it will not happen. So you keep changing your conceptualization, you keep updating your conceptualization until what your model is simulating is similar to what you are observing. Okay. And usually, like, you know, like a typical groundwater project, you know, like a typical groundwater model, like for the real case life, you know how much it would cost? Like if you went to like USGS, for example, to do one of these models for you, you know how much they will charge you? Can you guess? Like if I said, like I went to the USGS and I told them I need a groundwater model for like the South Florida Water Management District. They want to USGS, for example, I told them develop for us like or a consultancy company, a groundwater model for like South Florida. You know how much they will charge them? Developing a model like that. Okay, $10,000 here. Any other number? So they will charge them at least $1 million. At least. That's how much they will charge for a model like this. At least. You know, I was calling one of my colleagues in San John Water Management District, and he was telling me like they are not even developing a model for the whole district, it's just part of them. And I told him, did you contract the USGS to develop it for you? He told me, no, they are a little bit expensive. We contracted like a consulting company. I told him how much they are charging you. He said like 400,000. And they will like, so they will charge them about $400,000 to develop a model like this for them. And it will typically take like maybe 3 years to do it. That's how long it will take. I told him I should leave my job and just do like your modeling. You know, I just get like $4,000 over 3 years, and then I just work on one project. But anyway, but anyway, like what I want to tell you, like to set up the model, maybe it will take you like 1 year, but to calibrate it, it will take you like another year. Because like to calibrate, unless if you are experienced, like if you are an experienced modeler, it will be the other way around. Like because like you put so much effort in getting the right conceptualization, then it will just calibrate in no time. Okay, but like typically, what you are simulating would be different than what you are observing, and then you keep updating and improving your model, as we will do like next time. We will do like the model calibration until like what we are simulating is similar to what we are observing in the field. If what my model is simulating is similar to what I'm observing in the field, this means that like this aquifer in the real life, I have it now on my computer, and now it's like a toy that I can play with, that I can do any design. As you would be doing, like you would be like, so basically what we will do today, we will set up the model to simulate like the head here in each cell. What we will be doing like next class is that we will calibrate this model to make sure that the difference between the simulated head, so this is what I would want you to do. I tell you like the difference between the heads that you observe it at each of the 12 points here. So at each of these 12 points, I went like I want the head observe it, and like the head simulated is less than 0.3 meter. Okay. So this is like would be like a calibration criteria to make this head like less than 0.3 meter. Now, if what I'm observing in the field is similar, what my model is simulating is similar to what I'm observing in the field, this means that I have a representation of the subsurface of my computer, and I can use this for my model application, which we will do like not next class, class after. We will be doing some. We will use this model to do like a design, like ground water. But that is like the general like big picture. So that's the general big picture for what we will be doing. This class, for next class, we're going to do this, and like the third class, like we will be doing the application. Any question about this? Any question? Because like this again, like what I'm telling, what I'm teaching you here, like even if you are not interested in water resources, like you are a structural engineer, you are geotechnical engineer, like what I'm teaching you now, this is the basic concepts of modeling, of any model development. Like you create a conceptual model, then you set up like your numerical model, you simulate the state variable in interest, whether this is like head, whether this is a contaminant concentration, whether this is like stress in a beam, whether this whatever it is, and then you compare it to what you are observing in your experiment or in the field, and then you keep updating your model until your model is simulating what you are observing. Okay. So this is a general concept in any application. Like this is what I'm telling you. Like for example, like I tell you, like how much load do I need to put on this like table to break it? How are you going to do this? So one way to do this is that you can keep loading it until it breaks, and they'll tell me like 3 tons, right? That's like one way of doing it, right? Another way of doing it is that like you create a model on your computer. So basically, like you get like the geometry of this table, the property of this material, and then like your stress and strain like equation, you put them there, okay? But then how would you know that what you have in your computer represents this one? You do an experiment on this one, and then you see is the result of this experiment coming like similar to what I'm observing in my model. If they are the same, this means that this is a calibrated model, and now you can do anything with it. Now you can say now if it's a point load, then that would be that much. If it's a distributed load, that would be that much. If the load is from this direction, that would be that much. Okay. But this is the general concept, is that like you create a conceptual model, you calibrate it based on what you are observed, and once these two match, now you have a model that can do anything later with it that you want. Clear? Clear for everyone? Like, is this concept clear or not? For everyone, okay. So now let's just start. So let's just use MODFLOW. Again, MODFLOW, this is just software that simulates the groundwater flow, and it's like simulate like a soil for H. And then it could have so many packages that could do other things. It could have a package for like recharge. It could have a package for a pumping well. It could have a package for like river interaction. It could have a package for farm processes. It could have like a package for salt water infusion. There are so many packages out there. That's why it's called like a MODFLOW family. It could have a package for heat transport. It could have a package for contaminant transport. But all these applications depend on simulating the head in your aquifer. So basically, we will like in this class, we will like just like focus on MODFLOW, but like once you learn MODFLOW, you can use all these other packages like later depending on your application. MODFLOW usually like the way we enter like If I want to enter something like this in my MODFLOW, I want to define like these boundary conditions. The way we do it, we generally do this by programming, like this. Like when I did this, this is how I did it. But there are also some graphical user interface for MODFLOW. So there is also like graphical user interface for MODFLOW. The ones that we will be doing today is called like Model Muse. Model Muse, that's like a graphical user interface for MODFLOW. So instead of entering all these things and like these boundary conditions through programming, like using Python or whatever. So in Python, for example, you have a package called like FlowPy. You will just use a graphical user interface. The reasons that we are doing this one is very powerful and it's public domain software, it's free. In the industry, some people use this one, but the one that's more popular but it's not free is called, I think, Groundwater Management Suite, GMS. Groundwater Management Suite. This is like the one that's used more in the interface. Again, it's a graphical user interface, but this is like up to you. Like, you want to use this graphical user interface, you want to enter this like manually. Like, for example, like if you want to do this with programming, you have like in Python, for example, you have something called like a flow. This is with Python, it's called like flow. Again, what I will teach you in this class is like this one. Okay. So this is what I will teach you in this class. Okay, so let's start. Let's just use Model Muse. Let's open Model Muse and then use it to first of all like generate our grid. Like we generate like the grid where we'll be solving for like H value. Then after we generate our grid, we will enter like our conceptualization for like the hydraulic conductivity field. We will enter like this guy as a change in X, as a change in Y. And then we will enter our boundary condition, like the recharge that we have from the top, the pumping well, and the dripping. Okay, let's start. So like to do this, any question before we start? Like please ask me a question, because like now we will start working in your project. Like what I will be doing now is like I will be working in your project. But before, like this conceptual part for like your report, like any question. Is it super clear for everyone? Should be simple, right? Yeah? Okay. So let's just start here. So like to start this, you can, if you have it installed on your computer, you can do this. You can just launch Model Muse. If you don't have it, you can come here from apps anywhere, and you write like model. If you install it on your computer, it might be even better because you have a new version of Model Muse. But if you don't have it, that's okay. Install, then you run this one. Oh, let me, this is the steps that I will be doing. So just give each one, just print it for you. Thank you.
Stuck in I-75. Finish it now.
Nice will work.
I assume so. Our group's full though.
Yeah, I know. I'm gonna have to do it by myself. Thank you very much for telling me.
You could join another group that has less.
Everyone is fine. Except for a previous one, yes.
Sure.
Yep.
Okay.
They might not.
That's a discussion we have to have with your group.
Okay, so let's start with this one. So when you start model views, it will tell you like what you want to do, like create a new MODFLOW model or like open an existing model views project. So if you already have your project like set up, or like if you already have a project, you can do this one. But for this one, if you already have an existing MODFLOW model, you can import it so that you will have like a graphical user interface for it. So maybe you can enter it with Python, and then you, after you have like your model set up with Python, you can just view what you did, like you can import it and view it with model. Again, this is just a graphical user interface. So you'll just like create here like a new model. If you follow this step, you also have a copy for me. Like the right. Okay. Yeah, anyway. Okay, so here, like this is like if you want to have a project description, like projection, like the projection here, this will be just arbitrary, so you can just write like arbitrary. So that's like we don't have like any specific projection. Like the length that we're gonna use is like a meter, the time unit. Remember, like here, for example, like we defined our hydraulic conductivity as like meter per day. So the time here, you could select like day. You can change these later, it doesn't matter. Then you can create like next. Here it will tell you like the version of the MODFLOW we would use. We would use like for this like 2005 version. So you use this version. So you select here the model version. You select like this one, 2005. Here like the number of layer. Remember, like we only have one layer. So this is like our aquifer. We only have like this unconfined aquifer here. So we only have like one layer. The model top. So if you like check like the upper aquifer, like if you check like your project description here, so like in your project description here, I'm telling you that the base of the aquifer, and I've plotted this for you, is like a 90 meter. So like this base here, like this is like 90 meter here, and so that would be like we put here like 90. And like the model top, just make sure it's big enough. So basically the model top, that's like how far it goes. Make sure that's like big enough so that you don't get like your water table will not go to the surface. So we know like our largest head value, for example, like if you look here, our largest head value is 108 or like 107. So you just make it big enough. So I will just make it 120 because I will like, okay. The grid origin, you can keep it 0 and 0. Like for the tutorials that I posted online, I was changing this to another number. This is not needed because like you can do this like later. So just keep it 0 and 0. So that'd be easier, I think. Then so you keep this as 0 and 0. This is your grid origin. And without going into these technical details, but like just keep it 0 and 0. And then you create here no grid. I don't want to create a grid now. Okay. So basically, I will say like no grid. And then if you do this, each time you create a new project, Model Muse will randomly like start a new tutorial video. So they have like this tutorial video if you want to learn about Model Muse. So for example, here they start the introductory video. So like you can, that would be like
USGS and words, Science for a Changing World. Peer agreed, then beta.
Hello, welcome to Model Muse.
So that would be like, for example, the video. So each time you start it, it will start a new like tutorial video. Okay. So you'll have something that looks like this, and to start creating like our grid, let's just create like import like the image that we have for our site, and we can use this image to create our grid. So like you come here, you import, and like go to image. So you have like all this data like available on Canvas in your project, and you like do select. I have this in like go here, I think it's, yeah, it's a download. And this, you can select like this image, for example, which create, okay, then like you have the image is imported here. And then now you want to like assign like a coordinate, like or geo-reference this image. And again, here we are using this arbitrary, so it would be just more relative to what we define. So I would like to define like my origin here. So that would be like my model origin here, like my 0, 0. So this is like the boundary of my site. So I would like to define like 0, 0 here. So basically, like you click on this one, and then like the X here is like 0, and like the Y here is like 0. Okay. So I would like to define my 0, 0 here. And then here, if you go to the information that you are given, your project gives you like these information here. Like if you read like in your project, it will tell you like that this distance from here to here, that's like 4.5 kilometer, and this distance from here to here, that's like 1.5 kilometer. Okay, so this is the information. So now I could come to this point, and I could just click on this point. Again, the X here would be 0. So like the X here, that's like 0. So this would be like 0, 0. This would be like 0, my X is 0, my Y, that would be 1.5 kilometer. Here, this is like 4.5 kilometer. So my X here would be like 4.5 kilometer, my Y would be like 1.5 kilometer. And here, my X here would be 4.5 kilometer, and my Y here would be 0. Okay. So I will just like define these 4 points, and that will give me like the domain of my model. Okay, so that's what I will be doing. So here, like I'm selecting this point here, so that would be like 0. My X is 0, my Y is like this number, and I click OK. I select like this point here. Again, it does not need to be very accurate. You can change this later. This is my X is 4.5 kilometer. My Y is 1.5 kilometer. Right?
Right.
Did I do something wrong? Yeah.
You should go back to after you recorded that image. I think a lot of us didn't have it downloaded.
Okay. So like you come here, go to File, okay, Import. So go to File, then go to Import, and then like Image, and then you select, you here like Select Image, and then you click Open, and then like click OK, and then you start defining your point. So here, this point would be like your 0 and 0, like your X is 0, your Y is 0. This point here, your X is like 0, your Y is like 1.5 kilometers. Okay. Then you go here. Your X will be like 4.5 kilometer, and your Y will be 1.5 kilometer. And like you go here, your X will be 4.5 kilometer, and your Y would be your Y would be 0. Okay. Now I have like these points here. Now, like to make it a perfect square, you can just like adjust this manually. Like for example, like from here, for example, make this 55 so that like these two align. I could make this like 72 so that like these 2 points align. I could make this like just to get like a perfect square if my hand was not accurate. Basically, that would define like your 0 here. So that would define like this 100 here. So that's the pixel. So I just adjust the pixel so that like 0 would be 55. My 0 in the y, that would be like 422, and my, so you just adjust it, but if you want, you get like perfect, and then you click OK. And then after you do this, you can come and with your mouse like do this, or if you don't have a mouse, you can, I think, come here and like click here, and then you can zoom in. Okay, so that is smaller. Okay, and then if you want to get, okay, basically you can do this also. Then you will get something that looks like this. Okay. Now we this is like our site, and now we want to create like our model grid. Like we want to create our model grid, and for our model grid, I'm giving you like in your project description, I'm telling you, I want each of these cells to be like 50 meter by 50 meter. Okay, so this cell would be like 50 meter by 50 meter. This is what I'm asking you to make each of these like 50 meter by 50 meter. So to do this, Model Muse is actually a very powerful software. It has a lot of flexibility, and because it's very powerful, sometimes it's like you cannot make something very powerful and at the same time very user friendly. But once you get used to it, then it will like you will find it like not very difficult. So like in order to create like this grid, what I have to do is like Model Muse use object. So anything you want to do, you have to create an object for it. If I want to create like recharge, if I want to create my grid, if I want to create a river here, if I want to create a pumping well. So a pumping well, for example, that would be like a point object. A river, for example, could be like any of like these objects. So like for my model grid, I will just create like a rectangular object. So I will come here, I will like select this one, and again, you don't need to be accurate because you can, I will show you like how to adjust the vertices later on. And then you click OK, and then now you have an object that is created. And I will call this object outline, because this is the outline of my site. So I will call like this object outline. Now for this object, I need to define like the Z coordinate. So like the Z coordinate, for this object, you click here on edit. Okay, then you go to data set, I think required layer definition. Okay, and then you click on the model top. Okay, so that will be my model top, and you double click on it, that will tell you this model top. You see here, I told you like Model Muse is very powerful software. You could have like, you could do programming here. Like if you know like, but again, this is just like very rough, like this is very quick introduction to modeling in MODFLOW and Model Muse. So I'm not gonna go over all these details, but I'll just show you how to do it, because the learning curve for this thing is like steep. But I will just show you how to do it.
Can you do that step?
Yes. So you can cancel. Let's just, okay, you can cancel, and then you can hide here. Okay, let me hide this. Okay, so like you come here, you create a rectangular object. So I can come here, I can create like a rectangular object. I would like to give it a name that could be like outline, for example. That's like the name that I would like to give it. And then like the higher Z coordinate, I will come here, I will go to data set, required layer definition. I will do this like my double click here, that would be like my model top. And then lower Z coordinate, that's like the upper aquifer bottom. Like you double click on it, that will tell you that's your upper aquifer bottom. Okay. So now I have like this one. Then you click here, use this set grid, like use to set grid cell size. because this is, I want to use this to set my grid size like 50/50 or whatever. And then like my grid size, I will put like here 50, okay? Now I want to adjust the vertices of this one to make it like this edge. So you come here to vertices, and then now you adjust your vertices. So like this point, for example, like my first point, that should be like 0, for example, and that should be like 1.5 kilometer. This one, for example, that would be 4.5 kilometer, and that would be like 1.5 kilometer. Here, for example, that could be like 4.5 kilometers. That would be like 0. That would be like my 0, 0. That is like my 0 here, and that would be my 1.5 kilometer here. So if I click this, and I think that's all you need. Like, if you want to give it a name or something, you can do this here. There's nothing here. There's nothing here, and then yeah.
I think we were stuck at where you went on data sets. We're able to go back and do that because when we go into the settings there,
Okay.
the data sets, we could not find anything that you had.
What do you need data set? Oh, okay. Like, okay. Let's do it. Let's do it again. Okay. So you come here. Okay. You create like an object.
Right.
You give it like a name, like outline.
Right.
Okay. Then you set like use this to set a grid, and then you give it like 50.
Yes, we did that.
And then like you do this one, like the upper one. That would be like your model top. Make sure you get like this 0 here. Then you click OK. Your lower Z coordinate, that's the aquifer bottom. You did this one? Yes.
Model top, upper aquifer bottom.
Okay, I think he did model top into a different.
Wait, you model top and then do a different one, upper aquifer bottom.
Yes, upper aquifer bottom. Okay.
Yeah, I think he did.
Okay. And then like so for the vertices, you come here, you can adjust like the vertices here, just like 0, and this is just this one, just to make it like this is the 4.5 kilometer. This is the 1.5 kilometer. So you can do this like any way you like, and then you can adjust the vertices. Like this is 0 here, 0 and 0. This is like 0, and this is like 1.5 kilometers. And if you click OK, then like you see now, like if you click OK, now you see your that thing here now align exactly with your site layout. Yeah. You didn't get that?
I did itself because my image showed possibly
Okay, how about like let me, because like if I start to do each one of you the problems that you are encountering, that will take like 10 hours. Okay, let me just go through these steps, like show you the steps, and maybe next class I will go like after this class you can watch the tutorial and try to follow it, and next class I will come and see like what problem each one of you is having. But just because what problem were you getting like? Well, can you tell me exactly what's the problems that you got?
Oh, my image recorded different. So it might like yours fit the screen, mine just more dense.
Oh, because you need like because after you import it, you need to make it like you need to zoom in or zoom out. Like when you import the image, like I don't want to go back to the stage of importing the image, but like when you import the image, like if you come here and like click on zoom in, like you zoom in or zoom out so that it will like fit your screen. Otherwise, it will be small. Okay. But anyway, so like you can have like your like now you have an object. Like if I click on this object, like you can come here, like go to this like red thing. If I click on this object, that will tell me this is like my outline. I use this to set grid cell is 50. This is defined as like my higher Z coordinates, that's the model top. My lower Z coordinates, that's the upper aquifer bottom. You have a question? Okay, and then like my vertices are adjusted like to represent like what I'm doing here. So we have something that looks like this. And then now I want to create the grid, and like to create a grid, you just like come here, like subdivide the grid cell. So if I just, no, not subdivide, sorry, generate grid. Like you just come here and generate grid. So if I came here and just click OK, and then now I have my model here. Okay. So now here I have like this grid, and each grid size is like 50 by 50. So now I have here my model grid, like you see here is this, like if you read here, like just like this status bar at the bottom, that will tell you, for example, like this is 5 and 40 where I am. This grid here, that should be like 4, like that's about 4.5 kilometer and 30. Okay, this is where I am. Okay, so this basically you can check here. This is 4.5 and 1.5 kilometer. This is 1.5 kilometer and like this. Okay, so now I have like my grid. So I did this step. I will be able to like generate a grid, and each grid cell is like 50 by 50 meter. Let me just do the model setup. If you have a problem, like we will spend the rest of the class, I will come to you like one by one and see like what individual problems. Okay, but you get something like this. Now the next step, remember, like our objective is like we have like several steps here. The next step is like to define the hydraulic conductivity zone. Here in our equation, we need to define like this case, and then after this, we need to define like our boundary condition, like recharge, pumping, and river. So let's start with this guy. Let's like define our hydraulic conductivity. And again, like how to do this, you do objects. So now let's get rid of this object here. So to get rid of an object, like what you do is that you can click here, like on this guy, or you can go from like data, and you can, data, like object, you can click, which is also here, okay? Or like you just click directly on it. So you like click here on this guy, and then I want to select all that, like I want to remove like this object. Okay, now I will start creating my hydraulic conductivity field, which should look something like this. Like this, what we did last time, it should look something like this, and I don't have it with me, but anyway, doesn't matter. So what you can do here, like how you, like for example, like I want to create this zone, like I want to create this zone here. So how to do this? You can just like create a polygon object. So like you come here, and then I will create like a polygon. Or before doing this, like before creating the object, you need to define like your model parameter. What do you mean? Like before I do like this object, I need to define my model parameter. So remember, like I have like 6 model parameters here. I have like K1, K2, K3, K4, K5, and K6. So I have this different model parameters that I need to define. So like to do this, you come here to model and then manage parameters. Okay, and then you come here, you select like you need, like you have 6 parameters, and then you do them like, let's say this would be like my K1, for example. This is like my K2, this is my K3, this is my K4, this is like my K5, and this is like my K6. Okay. This, what type of parameter is this? This is HK, means the horizontal hydraulic conductivity. Could be other things, could be horizontal anisotropy, vertical anisotropy, vertical hydraulic conductivity, or this one. Okay, so you select like this is horizontal hydraulic conductivity, and it already select like the package that MODFLOW will use for this. Okay. Horizontal hydraulic conductivity, horizontal hydraulic conductivity, horizontal hydraulic conductivity, and here like horizontal hydraulic conductivity. Now I need to define like my parameter value. So what I have here, let me just copy the parameter values that I have here. So I have for this one, let's say, yeah, like 8, for example, like here, like I don't know, 21. This is like 300. For this one, I have like 41. For this one, I have 650. And for this one, I have like 150, something like this. Okay. Again, this is like my 1, my 2, my 3. This is, yeah, this is my number 4 here. This is my number 5 here. 1, okay, 2, 3. My number 4, for example. This is my number 5, and this is my number 6. And here is 150. Here is like for this one, I just put like 41. Again, like all these numbers does not matter because this is just like an initial guess, an initial conceptualization that we will be changing as we move on. And here for this one, for example, I put 3. Okay. So this is like basically my 6 hydraulic, my 6 parameter, and this is like again this is just an initial guess for this parameter. And next class we will show how we can update this guess. Okay, and then here, like after you do this, you have to click zone array. Okay, you click zone array because like we will use this to create like we will use this to create like our hydraulic conductivity like differential. And then you click OK. Now you have your parameters defined, and now we need to create like an object. So I need to create like an object here, for example, that would look something like this, and then I assign to it this parameter. I create an object here, and then I assign to it this parameter. I create an object here, I assign to it this parameter. I create object here, I assign this parameter, so forth and so on. Okay, so let's start by creating like an object here. So I can do this as like a polygon object. So I can just like come here, for example, like do this, do this, do this, do this. I mean, it doesn't matter. So like now I have my object, and like let's call this. This is zone 1. So this is my first like hydraulic conductivity zone, for example. So like I call like this is zone 1, and then I come here to MODFLOW. I come here to data set required. And then this is my hydraulic conductivity parameter. So now I have this parameter, and you have to select all of them. And I told you why you need to select all of them. So you select all of them, and you see the default formula is false, like, which means that it's not going to use the value for this hydraulic conductivity. But now, this one with like my parameter 1, like K1, I just want to assign it to here. So I make this one true. So I make this one true. So means like this zone, which what I'm saying here, like for this zone, like whatever parameters that I have here for this one, which is like 8, this is true, but all these other parameters are false. Okay, so you see here false, false, false. And I will show you why this is like needed. Okay, so now I have this one here. You can here if you want to make it visible or anything, then if we click OK, then you click OK, then now I have created my something that looks like this here. Can we view this? Yes.
I don't know if you were on MODFLOW features, but we're getting nothing.
We're getting what?
Blank.
That one.
There's nothing showing for MODFLOW, the MODFLOW features tab where you have the coordinates, we have nothing.
Oh, like you mean here?
No, we were at object properties.
Okay.
Where we were before.
Let me do this again. Okay. So oops. Okay, so let's do this again. Okay, so we come here, you create like a polygon object. You can do something like this, okay? Something like this, something like this, and something like this, okay? Then you click OK.
Right.
Then you can go like this zone 1, okay?
We got that.
And then you can go to data set, require,
Yes.
and then you select these guys.
Right, and we have K1 is true and everything else is false. We have that,
Yeah, so you make this like true.
yes.
Okay, then you click OK.
Oh, and that's it.
Yeah, that's it.
We saw something else, so we must have.
And then like if you want to visualize what you are doing, you can come here like data visualization. And then you can do like this, like color the grid. You can go here like your data set required. You go, I think, to hydrology, and then your KX, you want to view your KX. Then if you click apply, then you get like you close here, and then that will tell you, like you see, like look at my status bar here. No, like look at my status bar here. That will be 8, like you see here. Look at this value here, like the values that will appear here. Like this is 8 because now it took the parameter 1, which is 8, and like everything here else is 0. So this is 8 and this is 0. Okay, and I have like this object. Now I will just do the same for all like the other objects. So like now this is 8, this is the thing. I just want to create an image that looks like this. How can I do this? I just keep creating these objects. So let me hide this so that I can see my map again. So you come here like to hide these things. You come here to data visualization. You come here to none. You click apply and then like close. And then let me draw maybe like here. This is like 18 here, and this is a 41. So maybe let me create like another zone here. Okay. So like you come here, and then I can do like I'm creating like a rectangular array, for example, and then I create something like this, and I think this is what? Yes, this is zone 2, so I will call like this zone 2, for example, and then I go to my data set, require each parameter. You click all of them. By default, they will be false. I come to K2 because I want to assign my second parameter. I will make this as like true. Okay. And then now I click OK. Now, if I click OK, let me show you now what will happen. Let me show you the problem. So like let's do the get back to data visualization. You come here, your data set, you require hydrology, KX, and then you apply. Now, you see now the problem is what happened here. This is my K here is 0, and then my K here is 21. And like here, like these zones that I defined, it disappeared. It's no like same as 21. So that's what will happen. Like to solve this, you can come here, like do this select object. You select this object, okay, and then you come and you do like here forward 1, or like 2 from. Now you see here, when I did this, this became like 8, and this is like 21, and like the rest of it is 0. And that's why I have to do like select all the parameter and make all of them false. Because if I didn't select all the parameter, if I bring this to front without selecting the other parameter as false, basically it will bring this to front, but it will add the hydraulic conductivity of this guy to this guy. So the hydraulic conductivity here will be 8 plus 21, that's 29. But I'm not telling him this, because what I'm telling him here, like if I click here on this one, what I'm telling him is that zone 1 is only true, but like this is false, this is false, this is false. So and that's why I got like here is an 8 and here is like a 21. Okay, is this clear for everyone?
No.
Yeah, I'm gonna stop for like 1.
Can you redo the last step? I got the.
Yeah, let's do the last step. So like I could let me like delete this image. Let me like or not this one. Let me delete this one. Which last step, like the visualization or the second step? Okay, then let me delete this one. So I will delete this one. So now I deleted this object. If I deleted this object, this is like 8 and this is 0. Okay, let's remove the. Oh, let's keep even the visual. Let's remove the visualization. So I come here. I don't want to visualize anything. I click none. I click apply. I click 0. Then I come here. I select like a rectangular object. I can like come here, for example, like do this one. Okay. Then I give it like this. As I want to call this like zone 2, for example. For this zone 2. Like I want to like assign all the parameter, and I want this one only to be true, like my second parameter here. So I make this like guys like true here. Then you click OK. And then now I have this, then you come here to visualization. And if I come to visualization, my data set, you go to the hydrology part, like your KX, apply, close. Now I have a problem here. Why do I have a problem? Because now what I assigned here disappeared. So now this is 21. Like if you look here at the status bar, like look here, this is the status bar. This is 21, and this is also 21. So how to solve this problem? You come here, I select this object, and then I bring it to front. Now this became 8, this became 21, and here this is still 0 because I didn't assign anything. Okay. And that's why you need to, why this is 8? Because I am assigning here, like this is true, K1, which is 8, and like all these are false. If this is true, then it will add like these two values, but here it will be something like this. Okay, is this clear? Is this clear for everyone? Yes, okay. I mean, the rest is just like you keep doing it. So like the rest is that let me to keep doing it. You probably will not see, like you cannot see your background image. So like you come here, you select none. I don't want to see anything. And then you click apply, and then you click close. And then I could start like defining my other zones. So my other zone, let's say like this guy here, like this K3, for example. Okay, so let me define like this guy. So like this guy here, for example, to do this, I mean, rectangular object is not the right thing. Like polygon objects, I can like come here, like create a polygon object, and then I could come here, for example, I could maybe create like this guy here. Yeah, like see.
You're gonna.
I want to like, if you remember, like here is a boundary between like the high, like here is high hydraulic conductivity, this is low high hydraulic conductivity. I want to maintain this boundary. So maybe I do something like this here, okay, and then like out of this one, I get this values that looks like this here, and then this looks like this here. I mean, where to stop? Should I stop here? Should I stop here? Should I stop here? I don't know. I'll just stop here. Again, doesn't matter because if this is wrong, as I told you, your model will never calibrate. Like if what I'm defining here is wrong, if what I'm defining here is wrong, I will run my model, I will simulate my head. This head will never match what I'm observing in the field. So this is just like an initial guess. So I will just like come here, maybe do something that looks like this, for example, and here something that looks like this. I maybe stop this river again. Where is this river? Stop here, here. I mean, I don't know. I will just stop it anywhere. Doesn't matter. And then create like object. I think here this is like a high hydraulic conductivity zone here. Okay, so I mean, good enough. Then I will call this my zone 3. This is my hydraulic conductivity zone 3. I go to data set require. Now for this one, all these parameters I want them to be false, but for my parameter 3, and remember my parameter 3, like my K3 here, that's equal to 300. I want this to be true, so I select true, and then I click OK. And then now I have like this object here. I mean, I'm not going to visualize it. Let's just finish all of them and then we can do the visualization at the end. Oh, I know I have like, remember here, I have this high hydraulic conductivity zone. Or let me do this one first. Let me do this one. So I can come here again. I could create here like another one.
Do you get the colors to turn off again?
Say,
How do you get the color to turn off so you can see the image?
oh, so to get the color turned off, you go to data visualization.
Yeah.
And then like you select none. Like if you want to visualize it, you go to required hydrology KX, for example. So yours looks something like this. I mean, we can, like here you see this is 300, so it's already assigned. This is like 8, and this is 21, and this is still 0. To remove this color visualization so that you see the image, you can come here to like data visualization. And then you come here and then you select one. I don't want to visualize anything. Okay, and then you click apply and then you get back to your objects. Okay. Now I want to create like my last one. So to create my last one, like not my last one, I still have one. So like to create, like I still have two more. Like to create like this guy here, I come here. I want to call this like zone 4. And like in zone 4, I only want, like I select all of these parameters, but I only want this parameter to be true. So this is like true. Okay. This is like, you don't need to worry about this parameter because they are all false, like the default value for them is false. So this is okay. Then I have like this guy here. Now I need to put like another guy here. Again, this is my high hydraulic conductivity, so let me just put like another guy here. And I would go like this zone 5, for example, and like for this zone 5, you can go here 1, 2, 3, select all of them, and then like zone like my parameter number 5, I make this a true parameter. Then I click OK. And then like finally I need to define like this high hydraulic conductivity region near the river. So like to do this, I could come here, for example, and like create like another guy here. And it should, of course, like this hydraulic conductivity should be connected to these channels here, because otherwise, if this is not connected here, it's not your like this area is not going to be connected to the river. So you need like, so again, how to know these things? This is just come by your best judgment and like you're using your common sense. And if you don't have a best judgment and you don't have experience in these things, if you didn't do this, your model will not calibrate and you will not get good results. So you will know, okay, I didn't get a good result. Somebody will tell you because you're not connecting your high hydraulic conductivity fields. You're losing this connection between your main channel in the aquifer and the river, for example. So he will tell you like connect these. Come here, click OK, and this is like my last zone. I call it like zone 6. You can give it any name you like, doesn't matter. And then like you can select here, and then you use the keyword here true. So like make this true. And then now I have this like to visualize it to make sure like remember I need to visualize this to make it in the right order. So like you come here, required hydrology, you go to KX, click apply, and now let's check. Let's see what we have here. So this is 8, so this is correct. Now this is 21, this is correct. Now like if I look here, this is like 300, but this one is not correct because this is like a God 44. So like to solve this problem, again, you select here of the red one. I select like this guy here, and then I two back. I bring this guy to the back. So now if I brought this guy to the back, now this became now this became what I needed. Like so, here this is 300, and this is like 300. Okay, now this guy here, I want to bring like this guy to the front. I want to bring like this guy back, like this guy here, like near the river, like brings this. Like this one here, this already to the front, so you cannot do anything about it. Like now, like this small one here, I want to bring this to the front. And now this is like how my hydraulic conductivity field looks like. Okay. So I have like a channel, like I have this high hydraulic conductivity area, this is 150. So like if you look at the status bar, like look here, this is like 150, this is like 650. This is like 300, this is 41, this is like 21, and this is 8. Now I don't like all these objects, they don't look nice. So to remove these objects, you come here, and like I could like click here, for example. Then I have it like something that looks like this. Okay. So here I have now this looks better. Now this is K here is equal to 8, K here is equal to 21, K here is equal to 300, K here is equal to 41, K here is equal to 650, K here is equal to 150. Like you see here, like this object that didn't continue all the way to here, you can change this. Like if you want to continue, like how to do this, like you can come here, you could go to like the required object, like your K parameter, like okay, the zone. So I could, like I think this is zone 3, I can just select zone 3 here, close this one, because I want to like redefine this one. So like how to do this, like you can come here and I think you can do this one. You can select vertices. So I can select like the vertices on this one, which is maybe like this vertices here, and then I extend it to here, for example. Okay. See now I extended this vertices to here, then I could do this. Like this is just to edit your vertices. You can, like if you want to change these zones. Okay. Again, like now I can select here, I want to hide this object. Again, like the two most important thing for you to know, this is to show and hide object, and this is to data visualization. So I want to hide this object, I come here, I unselect this one, so I click OK, now this object is unhidden. Okay. Now it looks fine. I mean, this looks fine. I have here, this is like 150, this is 650, this is 300, this is 41, and this is 20. Okay, so we have something that looks like this. Let's maybe take like 5-minute break or something, and then we will get like, let's get back at like 9:35, and like at 9:35 we will look at we will see how to like add recharge, how to add a pumping well, and how to add reverse. Yeah, you have a question?
I got stuff.
Yeah, I got a question. Real quick. So I think it's that whole flow through.
Oh, because you need like bring this to the back.
Okay, sorry. What do I do?
Bring this guy to the back.
This.
Yeah.
To the back. Okay. Well, actually, I guess how do I get the part of it?
You make it.
I did.
Where?
I made a zone. I don't know where it's not showing.
Okay, so like, oh, okay, you go here. Go here.
Yeah.
No.
Sorry.
Yeah. This one. Oh, yeah, this one. Like hide and show. Okay. And then like, yeah. No, like, yeah. You have. Oh, you don't have some.
I did.
Probably, yeah. You didn't do it because probably like just do it.
Yeah, all it, yeah, so.
Might be easier to use a rectangular object. Give it any name.
Just make 6.
Yeah, maybe.
Sorry. Yep. Oh, there we go.
Okay, now go to visualization.
No.
Yeah, because that's okay. If you hit escape, yeah, if you go like yeah, you already have the visualization. Yeah, you already have it. Like check like here. Go to your mouse here. Go to your mouse here.
Yeah.
This is cool.
Sorry, it's touch screen.
Go to your mouse here. No, just don't check anything. Just open your mouse. This is 8. Go down. This is like 21.
Okay.
Go here. This is like 300. Go here.
It's 150. Go here.
Oh,
This is 150. Go here.
thank you.
But you have a problem here?
Oh, yeah. This now is not connected to the river, so you need to.
I can extend the vertices on that.
Yeah, so you can come here.
Yeah, I was trying to follow smartly.
That's okay, I mean, if you didn't follow this, like, I have already.
But I get it.
But I did all that day short.
I was added the vertices.
I know, I left my house at 6:30.
Let's,
2 hours.
click on the vertices. Yeah,
And drag it in.
yeah.
Yeah, they shut down on 75 at Colonial, so then I had to get off 75.
Since then, like,
Since they shut down 75.
That's okay, that's fine.
Every other road is like.
Yeah, yeah, and you can shorten it.
I
Yeah, because we don't know what's true. I mean, when you can create a model, you see this is true. Now, like,
Shut it down. Colonial to the.
yeah, I think we- yeah, you just,
Usually, that's the only reason why they shut it down.
Like
It's
this
either
one.
that or hazardous building.
Clicking this over,
yeah.
like, so vertices also.
So just go.
I ended up taking,
Yeah, brings this guy,
the
like,
metro
extra
extension,
labor.
so we go.
So, it's like, yeah.
Hey,
Oh, so what I'm doing right now. And that should fix it.
Yeah, so now I think you're okay.
Okay, thank you.
And you will like.
Is there a way to add vertices?
I see there is like, okay, I think, yeah, I think.
You have a handout for this?
Yeah, so, yeah, like I have my.
Sorry, 75 was.
Yeah, I mean, I think people, yeah. So like, this is a handout, but also I have like a tutorial video, like if you go to the project descriptions, there's a tutorial video with everything.
Okay.
We did today. And then I'm also recording this lecture, so we have like basically three things. I have this, we have YouTube, and we have the lecture recording, and we have.
Whatever. Guys, I just later and then you upload it.
What? Okay, so this is.
It's got a little bit of a different.
Hey, oh, you're making a document?
Yeah, I'll send it to you.
Okay, you wanna like share it on Word?
Yeah, I'll just send it to you.
That blue book.
Oh, that would do
Share with all of our.
Oh, okay, all
I think that's what we did.
right.
Oh,
Okay.
yeah, you might as well use the exact same file.
Yeah, I
It's
just
the exact same
downloaded
template.
but it's
Much more for us. I have like, project, so I probably could start on this.
And then it will not be.
You guys are still.
Concrete?
Yeah.
They extended it until Saturday. Yeah. Or I'll look at what you did.
Yeah.
As like reference.
Oh,
All it was like Whoopi.
12
That's project planning.
Yeah.
So what do you?
Concrete, we have to design.
Oh, you're doing your
Design a TV. The blue beam one, you already said that. You're, I already have two examples, I think I have yours and Scott's.
Better. So hide and seek. Hide and seek. This is the. And they don't have
It's all right.
Then like, yeah, like, like insurance and everything.
It's gonna take much longer. I'm up to the stuff that he's on. And he's literally setting up our project, so we'll just use my project file. Okay, Johannes is actually setting up the Word doc right now. He's gonna email it to everybody. But but Scott, he's recording that, so you can rewatch.
Yeah,
the movie.
see if I can catch up with you guys. Don't say anything.
You're not gonna be able to do this in like 10 minutes. It took like me booking a bunch of times to repeat stuff.
Like, what we're doing right now is just like exactly for the project.
I think so. You're up to date on this too?
I got stuck a lot.
Yeah, I'm up to date.
I'm gonna go
My
back.
model doesn't look like him like exactly, but he came over and checked it like you're good.
I mean, I think as long as your K value.
Yeah, he's like everyone's estimation is different, and I'm just trying to model
Yeah,
as
but
fast
you
as
still
I
get the value.
I'll just.
Yeah.
If
You hover over.
Yeah.
That'll probably be-
What I'm saying is like, are we gonna use this design for the project or is this just like an example?
I assume the project is, you go under project, like you said, in Canvas, and this is the image, and that's the only thing we've studied.
I guess.
So, I guess it's helping us.
If he's just giving it to us, I'm not complaining.
I'm not complaining. We do have one good one.
What's this deal? A couple weeks.
Then like the 28th.
Yeah.
I think it's October 28th. As soon as I finish the IPR
We had
one
time.
and project planning, we'll work on this.
Oh yeah, I gotta do the project.
Let's do Tuesday.
You need a bar with that?
Now, we still have to do our overall site plan and we're getting HVAC estimates. All out. Yeah, I don't even look at that yet. That's not for IPR, we're the second submission. And I'm the only guy who has a headshot. I'll get my group. Project planning, you have to have like a go sheet about everybody's experience. You have to upload a headshot.
Now we have.
Yeah, that's easy.
Can I just take your?
Yeah, sure, yeah, please. Yeah, that's like for all of you, like if you want to attend the afternoon class, I do the same thing at 1 p.m. If you want to attend, anyone is welcome.
Do it again.
Let's do this.
Okay, that's not a problem. If you have another class, I already like.
Class leader?
Recording. So I
Do you have class leader?
I recorded like all of this.
Not very.
Okay. Hey, Scott.
And then I'm recording this class. Of all the
What's that?
Posting a recording.
Most of the. Like.
Oh, yeah.
He'll probably post it like maybe an hour after this conference is over. It's gonna take a while for the recording to
How long do
upload.
we have for this project?
It's
28.
Like I told you, right? Like, this main chapter is connected. This line of code.
Yeah.
So, I don't wanna leave that. It's over for Scott.
Said there might be a way to do that.
Hey, Austin, how many people in your group?
For this.
Yeah. Yeah, join your. I have asked that, but like. Hey, for this. No, it's fine.
That's
Maybe I'd have to discuss with Robert.
That's fine, I just want to ask this, I just got one before that, so.
I was born, I didn't mind.
Seems like this.
Wendy.
Yours is out.
Yeah, if you can get the radio.
I was gonna say, go ahead.
Yeah, you share.
Add the Bronx, and all of Long Island.
Why does it come through you?
You're a good leader. All good. Okay?
Guess what?
Now. Okay, let's get back please so that we can finish like the model setup before before like this class.
Just do the lab.
Okay?
My whole family, we're like, we're done with this.
Okay, let's get back please. Let's get back with this one, please, okay? So what we have done so far, like this is our equation again, like for those who came late, this is like our equation. This is what we are solving for. MODFLOW will simulate the head, but for MODFLOW to simulate the head, we need to define like all the other terms of the equation. So one of these terms is hydraulic conductivity, which we defined here. And again, this hydraulic conductivity, as this equation is showing, it changes with x and it changes with y. You can see. Okay. Now, the other term of the equation is like what's happening as a boundary of my system. So what is happening as a boundary of my system? I have something on the top, which is like recharge. This is like occurring from the top. So let's just add this one. Let's just add this recharge. I have like a pumping well that will pump water out, and then I have like a river. So these are like the three boundaries that I have. Other than that, this is like I'm telling you, this is a groundwater device. So this is a no-flow boundary. This is a flow direction. So this is a no-flow boundary, no-flow boundary. And like the bottom of the aquifer here, this is also another no-flow boundary. Okay. So let's just add these. So like to add this one, we need to add these packages first. So you come here to model, you add the packages first, and then you come here to packages and programs. So this is the packages and programs you want to use. Okay. And then like here is our boundary conditions. So like again, these are like the three types of boundary condition: specified head, like if I have like if I move the head here, I want to specify it. And this is like a specified flux. So this is a specified flux. This is like the recharge and like the pumping well. So like I select these two. Why this is a specified flux? Because here I specify the Q. I tell him I want to pump that much. I will specify the recharge. This is how much recharge I'm getting. So specified Q, specified flux. This means I'm specifying like the Q. So this is called like a style. Like this is called like style 2 boundary condition where I specify like the Q. This is like big Q or like small Q. This is called like a type of boundary. So and for this type 2 boundary condition, I choose the recharge package. This guy and like the pumping package. This guy. Okay. Then like the head dependent flux. Remember, like at the beginning of the class, I asked you like this question is like a river, like we have a river here. Is this a source or a sink there? And you told me, one of you said it's a sink and other said like it's a source. It's both. Because it depends on the head. If the head is in the river is higher than the head in the aquifer, then the river will feed the aquifer and it will be a source there. If the head in the river is lower than the head in the aquifer, then it will be a sink there and the aquifer will feed the river. And this is called like head dependent flux. So basically, what MODFLOW will do, it will calculate the head here, will calculate the head here, and based on this head calculation, it will estimate like how much water will flow from the aquifer to the river or from the river to the aquifer. And for this, you need like to make some, you need to do like some definitions, which we will do. We need to define, like, for example, the hydraulic conductivity of the river bed. So this is like the river bed. We need to define like the hydraulic conductivity of the river bed so that to see like how water will flow from the river to the aquifer, for example, or from the aquifer to the river. Okay, so you need to define like this, and we'll talk about this later. But anyway, let's just select. We are now just selecting what we want to do. For the head dependent flux, you can have all these things. Again, for your project, I only give you like a river. Okay, but you could have like all these other packages. Remember, I told you MODFLOW, this is just would simulate the head, but there are all these other programs that are related to MODFLOW that can do so many other things. What we will do in this project, we will just do a river. Okay, so you just select like a river. So you select your packages. Did all? Okay, let me one more thing. One more package like other than the boundary. Like so here, this is like my recharge package and well package. And for my specific, like I don't have a specified head for the head dependent flux, I select the river package. One more package that I want to do is like the observation package. Because now we are also doing observation. Remember, I gave you some observation data. in the field, and we need to compare this observation data in the field to what our model is simulating. So you also select like this head observation package here, because this is like also another package that you can. This, for example, surface water routing, if you want to do something like this. Here you could have different types of observation, not necessarily head observation. You could have like river observation, you could have stream observation, you could have drain observation. You could have like many different types of observation. MODFLOW also has another program called MT3D, which can simulate like solute transport and heat transport. Then your observation would be like the concentration of a certain contaminant or like the heat temperature. Okay, so that you are measuring in this place. But here we are not doing these things. This is again just very simple. We will just do head observation. Okay, this is what we are observing in the field. But for example, like the projects that I showed you earlier, like this contaminated sites that I did the remediation there, our observation was like head observation, and it was also the concentration of the contaminant of the subsurface. Okay, so now we selected what package we want to use. Now let's just do it. So let's start with the recharge. So with the recharge, again, how could I define? Like recharge, I'm telling you in the project description, assume that recharge is constant over your model domain. You have like one constant recharge. For your model application, that recharge will change, because like for your model application, I will tell you, you will have an industrial zone here that will plug recharge. So like recharge will be zero because you have like impermeable pavement or something. So that will plug recharge and recharge zone will be constant. But for the case of constant recharge, like I want to define like same recharge over everywhere. Here is the model, like how to do this. Again, like I told you, MODMuse is like it's just all same strategy. Like you create a rectangular object. I select my whole domain here. Okay, then click OK. Then I will call this like recharge. And let's give it a name so that we will differentiate it from like recharge. Like let's say background. Or I don't know what like let's call this recharge like base case. Because like later on we would be creating like other different recharge zones, but like here we just like we can give it any name and just differentiate it from the other recharge zones that I will create. So this is like the base case. And then you come here, not to data set now, you go to MODFLOW feature, and then you select like your recharge package. So like let me show you here. This is the package we have activated. We have activated the recharge package. We have activated the river package. We have activated the well package. So I will just select like recharge package. And now here's the start time. This is important. So like the start time, this is a steady state condition. Remember, like H is not changing with time. So here we are doing like steady state, like H is not like changing with time. This is a steady state. So for steady state condition, we generally start from like -1, and like the end time would be 0. This is the convention. So this is the modeling convention. If you are running steady state, because like usually before you do a transient model, you create a steady state model, and then you use this as your initial condition for your transient model. So the steady state model will run from -1 to 0, and then your transient model, like that, where it is changing with time, it will run from 0 because you start counting time from 0. So it will run from 0 till like 1 year, 2 year, 10 year, 100 year, whatever number of years you want to run it for. But now, since we are doing this in a steady state conditions, we start from 0 and the end is 0. And again, why am I ending with 0? Because if I would later want to do this, like see changes in time, then you start counting from 0. Okay, but for this case, here H is not changing with time, so here this is okay. So this is this one, and then like I'm giving you like the recharge that I'm giving you. So let's see here, like the recharge I'm giving you already recharge as like 0.8 millimeter. Okay. So the recharge that I'm giving you, this is like a 0.8 millimeter. Again, like remember, like the unit we defined at the beginning of the model, we defined like liter per day. So I cannot enter here this as like 0.8 millimeter So I have to enter this as like point like 0.008 meter. Make sure that you enter like like every unit you enter is like consistent. So I just convert like millimeter to meter. And this like this very realistic recharge for like South Florida. Or like this is like yes, this is like very realistic charge. Like I put like this data here. Don't remember this number. Just try to make it like something realistic. Yeah, and recharge. Yeah, like let me tell you like how did I get like this value? So, like how did I get this value? Like I assume, for example, like the average rainfall like over like South Florida, you got like millimeter per year. That's like the average like rainfall. So that will give you about, you divided this, that would give you about like 4 millimeter per like day. That will give you like 4 millimeters a day of rainfall. Remember, like not all this rainfall will like infiltrate in the subsurface, and not all the water that infiltrate in the subsurface will recharge the groundwater. So if you assume that like 20% of like your rainfall will like recharge the subsurface, then you get like 0.8. So that's how I got this value. So let's do this one. So let's put like a recharge of like 0.0008. So now I have like recharge here. So start from -1 and end at like 0 time. Okay, and then like if I click OK, now I want to visualize this. Let's hide all objects first. So like I can come here. Oh, you can also hide all objects. Like if you go here, you can do like hide all objects. So like that's like if you go to object and like hide all objects, you can also click here. Now I want to visualize recharge. Then how to do this again? Like this is the most three important thing when using this software is like this guy here to like select an object, and like this guy here to show or hide an object, and this guy here for data visualization. So like click on this guy, and then now you are here. I don't want to this like select none, for example, and then now you want to visualize your boundary. So you go here to the boundary, and then you go to like recharge, and then I want to see like recharge rate. Okay, so you select like recharge rate, you apply, and then close, and now like you see here like the recharge rate. Like look at the status button here. That will be like different for your project. You'll be creating like different zones, so you will have like it will not be constant. Like you'll have different zones and of recharge, like one for the industrial area, one for the irrigation area. So for your project, like for like not your project, for the project application. Like now we are just calibrating this model in the current condition before we start playing. Then you can come here again. You can go to this guy. You can select like none, and then you can click apply, and then you can click code. Okay. So I have like now defined my recharge. Let me do the river. So like the river. Let me show you like how the river is conceptualized. Running out of space. So like the river, like so this is like your multiple cell. Okay, so this is like your multiple cell, and then you would put like a river like the top of your cell. Let's say the river covers your whole cell. Okay. Let's say like the river covers your whole cell. That would be like, I don't know, you cannot see it in the back, it's like too small. Okay. Let's say this is like multiple cell. Okay. And like your river will like, be here, for example, that would be like your riverbed would be here. That would be, for example, like the river stage, like the header side of the river. Okay. So basically, so that's like that is the head of the river. And like this is like your cell here. This is like your cell here. So like this cell, for example, it will have this dimension would be like 50 meter, and this dimension here, I think, start all your model will start like this would be like start here at 90, for example, and here is like 120. So this would be like what 30 meter. That's like the model cell, and like the river will sit in the top. And like in this cell, let's say this is the head. Like you are measuring like the head here at this point, for example. Okay. You are measuring like the head here at this point. Let's say like your head here. So your head here is like larger, like that. Your head here, like the head here is equal to the head here. Your head here is larger than the head here. In this case, then like the water will go from the aquifer, will vertically go to the river. If like the head here is like lower than the head here, so I measure, like for example, the head would be like here, for example. If the head here is lower, then the water will go from like the Q will go from like the river, will vertically flow from like the river to our aquifer. Okay. And you can apply Darcy law for this. Let me delete this because you already know. Let me delete this one. Let me like delete like this one here, and you can like apply Darcy law to know this. Like so, like for example, like Darcy law, that's like negative k. I will just drop the negative k a delta h over delta z. Okay, so delta z here would be like the distance being like your h. Okay. So the K here, that is the hydraulic conductivity of like the riverbed. That's like the hydraulic conductivity of like this riverbed. Your delta Z, that would be like your delta Z. Because you are measuring like head here and head here, that would be like here. That would be like delta Z. Okay. And the area, that would be like 50 times, however, like that long, river is long. So like if you have like a river, like in 3D, like it would look something like this. So like, I mean, that would be another like 50 meter. So that would be like your area, like the area that steel is coming off. But like in your project, I'm telling you one thing, and here's the problem. Like I'm telling you that your river width is not like 50 meter, your river width is like only 40 meter. So how can we solve this problem? Like, do you see like here, I'm telling you like your river width is like not 50 meter, it's only 40 meter. And like remember here, each of these grid cells, is only 50 meter. So how can we solve this problem? Can anybody tell me? Like, you know, like your river should be defined here. Like your river should sit on the top of these cells. But like this cell is 50 by 50. I'm telling you, your river is only width. The width of your river is only 40. While like the width here, like this distance from here to here is 50. How can I solve this problem? Can anybody tell me how to solve this problem? Like, do you understand the problem? Yes or no?
I understand the problem, it's just how to apply it here is a little.
No, not how to apply it here, how to solve it in general. I'll show you how to apply it. Like the only way to solve this problem is that like your last cell, like your last column of cell, you just subdivide it. You subdivide it instead of like making it 50 by 50, you make it 50 by 10. Right? So if you subdivided it, make it like 50 by 10, then now I can say like 10 interval here, 10 interval here, 10 interval here. So that's what we're gonna do. Like the problem is, I want to have a river that's set on the top of these cells here. But the river, like this distance from here to here, that's 50 meters. And my river width is only 40 meters. So to solve this problem, all these guys, I just divide them into like 10 meter, 10 meter, 10 meters. So that cell, instead of being like 50 by 50, it would be like 10 by 50. Okay? And like to do this subdivision, how to do this? Like you go here like to your grid. So like you see this grid, subdivides the grid cell. Like you see this guy here. Like you see here, subdivides the grid cell. And then like you select this grid that you want to subdivide. Click on this one. And then now it tells you how do you want to subdivide it. So I want to subdivide this into 5 columns. Because this is 50, if I subdivide it into sub column into 5, then this means that each one will be like 10 meters. So if I click OK, then now you see here, click select. Now you see here, like my last cell now is multiplied. So this is 50 by 50, but like here, for example, like you see here, this guy is like 50 by 50, but this guy here is like 10 by 50. 10 by 50. So now, if I want to add my river, I will add my river. I will like select this guy here, select this guy. I will just select 4 of these, and that will give me the 40 meter width. Okay, so let's now add the river. So like to add the river, let's just come here. Like adding the river could be a little bit tricky, especially if your mouse is very sensitive for this computer. But let me do it here. So like. Just right here. So, this selection. I will like just, you have to be careful. Let me hide this image because this image is annoying me. So like if you go to like edit, like hide the image, you go to edit image, and then like click here, like to make it invisible. So like make it invisible, like if you click here, then it's okay. Now this looks much better, right? Now this looks much better without this image. And now like to add a river, again, you like everything here is by creating an object. You create an object and you need to be careful. Like, so this is like 1, 2, 3, like here's 1. So I'm selecting 1 cell, this is like 10 meter, another 10 meter. This is like 20, 30, and then like 40 meters. So I do this one, and then like I do this one. So now like see here, 1, 2, 3, 4. So like just select these 4, and then I will call this like river. Okay. I will call this river, and like if I click OK, for example, I mean I need to define something for it. This is the river. I will tell you about. I mean, let's do this like the starting simulation here is 0. The river stage, this is the head in the river, and like I'm giving you like this information is giving as like 100. So the river stage is 100. The river bottom, I'm giving you this information. So the bottom, like the elevation, this river bottom, I'm giving you this information also in your project as 95. And like is conductance, I will do this as 50 now, and I will show you in a minute like how did I get this. Okay, so click OK, and then now if I did this, then now I have the river. I can like come here. So want to come here, object, like hide all object. Now I should have like a river here. I don't know if I can. This is like, let's see, maybe we can visualize that box. So if you go here like river, like river stage, for example, like this like the head in your river, so that's like 100. So like you see here now, I was able to do what I was able to do what I wanted to do. I have like this is like I have like my river stage here is like 100, 100, 100, while like here this is not defined. Okay. This is like my river stage here. So now I have like a river here. The last thing that I want. Any question about like how to add a river? Yeah.
Can you just repeat what you made?
You want me to repeat it?
Just for the green.
Okay, so let's repeat it. So like to repeat it again, like how to do this, you have to come here. Like you have to select the MODFLOW features. You have to select like the river. Then it's like suppose now I have this object here. Oops.
Wait, can you redo that one part just one more time?
Okay. Now I will delete this object. So I will come here. Okay. I will delete the object, the river object. So now I don't have like a river. Now I deleted the river object. Okay. Now I don't have like a river, so I deleted like the river object. Then I will add. Is this the part you want me to repeat? Like how to?
We were at show or hide objects.
So how to hide? Like if you want to hide all objects,
Show it like the yellow.
no, how to show like a river? Okay.
Yeah.
No, like how to visualize a river or how to show the object of a river. It's different. Like how to show the object of the river, you need to first to add it. So let me add it first. So like to show the object of the river, I just deleted it. Let me add the river first. So like to add the river, you come here, make sure that you select like 1, 2, 3, 4 of them. Okay. And then like you, so now this is the object. I will call like this river. Okay. And then like you go to MODFLOW feature, you go to like river. Start time again is 0, 1. The river stage, that's like the head of the river. This is like given as like 100. The conductance here, you put this as 50. I'll explain this in a minute. And the river bottom, this is I'm giving you this in your project as like 95. So this is easy thing you can measure from the field. Oh, one more thing, please. Like here for the hydraulic conductance of the river, say this is direct. This is not hydrated. This is like direct.
I like go back.
So like here, this is like make sure
I like go back.
when you have like this, makes this is direct. So again, then if I click OK, then I will have like this object of the river. If I want to see what this object has, I come here, select object, I click on it. If I click here, then I will have this is a river. This is my MODFLOW feature. Start at -1, end at 0. The river stage is 100. The river conductance, that's 50, and make sure that this is direct. And like the river bottom here, that is like 95. So make sure that you have something that looks like this. River stage, and make sure that this is direct, because if this is not direct, this will not be correct. So now you click OK. Now like you go to visualization, like how to visualize this. Let's start from the beginning. So let's say I'm not, let's apply tools. Now I want to visualize like the head, for example, in the river, like the river stage. So how to visualize the river stage? I could hide this object or I can keep it, it doesn't matter. But like here, to come here, you go here, boundary condition, river. If you want to visualize the river bottom, river conductance, or river stage, I want to see like, for example, the river stage, I click river stage, I click apply. And then now I can see like I have a river here, 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 but I don't have a river. Let me hide the river object. To hide an object, you can show here like hide all objects. If I hide all objects, then I have, this is my river like stages here. Did you all get this one? Yes? You got it here? Yes, I see you got it, right? Yes?
Yeah.
Good, yeah.
Yeah.
Okay. Now one last thing is like this river conductance. Like how did what is this river conductance? Remember I defined like the river conductance, like the conductance of the river. I define this as I don't know 50. And this is like meter per day. What is this river conductance? Basically, river conductance, you see like the cube that will go either like from your river to your aquifer or from your aquifer to your river, like this is both way. That depends on the hydraulic conductivity of the river bed. And that depends on like the area. And that depends on like your delta Z that you have here. Your area again, so your area that would be like the area of each cell. So now each cell is like 10 meter, because like Q is coming over like 10 meter, and like each cell is 50 meter, okay? So that is this area. So like the area here, or before I tell you what's the area, let me tell you what's the hydraulic conductance. So the hydraulic conductance is that like this is my Darcy. If I just write it like this, like Q as a function of like delta H, and again delta H here, this is like the head in the river minus like the head in the aquifer. The head here minus like the head here. Okay, but like if I rewrite this as like my K, my delta Z here, or my Z, whatever, like this is my Z here, and this is like my delta H here, like this guy, like these guys, like these three guys, this is called the hydraulic, this is called the river conductance. So the river conductance, like CR, like the river conductance, that's like your hydraulic conductivity of the river bed, the area over your delta Z, which is given here. So now, if you did this, if you can take like that's like your hydraulic conductance. That's like this 50 that I defined here. Okay, and that's what you need to define. So this is given. Like in your project, I think I gave you this one, whatever like this value is. So like if you go to the slides, like this is given, and you can see here. Okay, so like this is giving like the hydraulic conductivity of your riverbed, like the hydraulic conductivity of this guy. Here is giving like 0.02. The area, again, the area is like the area where Q is passing to the river. This like this 10 meter, like 50 meter. So this would be like your 50 meter times like your 10 meter, and like your delta Z here, that's like the thickness of the riverbed, and like the thickness of the riverbed, this is also given as like 20 centimeters. So this is like 0.2 meter. And if you did this, this will give you like a hydraulic conductance of like 50 meter cube per day. And that's the hydraulic conductance for your river for each cell. Because like this is the river is sitting on the top of each cell. So for each cell, this is the hydraulic conductance. Okay. In your river. And of course you have like different cells both in the X direction and in the Y direction. So like in the Y direction, you will have in the X direction you have 4 cells, each is like 10 meter, and in the Y direction you have 30 cells, each is 50 meters. Okay. Is this clear? Is this clear? Is this clear for everyone? Yes? Clear? Okay. So this is called the river conductance, and these things you can easily like measure in the field. Like if you are doing like field investigation, you can easily like get like this value, you can get this value with different methods, and this value, like your hydraulic conductance, it could vary across your river. Like for example, like I told you, when I was in Ireland, for example, this exchange between surface water and groundwater is not happening everywhere. It's only happening at certain locations. And you can know this location very easy by heat tracing, for example, because surface water and groundwater, they have different temperature. So with just like, if you have something that can measure temperature, then you will like see, okay, like here is a different temperature, here is a different temperature. So you can do this heat tracing, and like for each, you can get like for the areas of your river, like stretches of your river that has high conductance, you will have like a different value that stretches of your river that has low conductance. So in the field, like you can measure these things. They are not difficult. I mean, they are doable. This is easy to do. Because remember, surface water is easy, because surface water, this is something that we can see with our eyes. We can do more things than groundwater, which is invisible in the subsurface. So for example, like I surveyed like a whole scheme, maybe like to see like different conductance, different hydraulic conductance. That will be like one day work. Yeah, I think we are done. And like next time we will run this model, and then we will start that.
Sent everyone the file. send you